Bismillahirrahmanirrahim. Motion of objects projected at angle. And these motions are called the projectile motion. For example, if we have a ball and we throw it with a velocity vi at an angle of theta, then this body or the ball will move in the upward direction with the initial velocities vix and viy, the initial velocity components, where vix is a horizontal component of velocity, initial velocity, and viy is a vertical component of the initial velocity. Initially, as the body starts at time t is equal to 0, its distance along x-axis is 0 and its distance along y-axis is 0. And the initial velocity is vi, where vix is equal to vi cos of theta and viy is equal to vi sine of theta. Now, when the ball moves in the air, it moves as follows. Its motion is accelerated motion. The acceleration is constant and downward only. It means body is falling under the acceleration due to gravity. Our body is moving with an acceleration due to gravity. And this acceleration is only along the vertical axis, but the horizontal component of the velocity is constant. It means that when the body moves in the projectile path, its velocity components, means x components and y components, and the only y component of the velocity changes, but the x component of the velocity doesn't change, as there is no force along the x-axis. There is only one force which is acting on the body, and that is the force due to gravity, and this force is along y-axis. This is the vertical component of the force, and it affects only the vertical component of the velocity. So velocity along x-axis doesn't change, and the body moves with the constant velocity along the horizontal direction. So the horizontal and the vertical motions are independent of each other, but they have a common time. And the acceleration, vertical component of velocity changes with acceleration a is equal to minus 9.81 meter per second square. From this discussion, we can analyze that the projectile motion, in the horizontal direction, velocity is uniform, but in the vertical direction, that motion is an accelerated motion. Accelerated means velocity changes. Our speeds up, our speeds down. During the upward motion, the velocity of the object decreases, and during the downward motion, velocity of the object increases. So, the vertical component of velocity continuously changes with a rate of 9.81 meter per second square. And it is noted that it is assumed that there is no air resistance during this motion. So, for this purpose, we overall draw a table for the different components or different parameters of the motion along x-axis and along y-axis for comprehensive view. As far as the acceleration is concerned, there is no acceleration along x-axis, so ax is equal to 0 and ay is equal to minus 9.81 meter per second square. And the velocity As far as the velocity is concerned, the velocity component along x-axis throughout the motion remains constant, and that is equal to the vi cos of theta. You know that vi cos of theta was the velocity initially projected when the body was thrown. That body was given two components of velocity. If we throw a body in this direction, it means that body has two velocity components. The velocity is moving at the start with Vix along x-axis. It has the ability to cover a distance of value Vix. If Vix is equal to, let's say, 6 meters per second, it means that body throughout the motion of the projectile will have or will retain its velocity along x-axis, and it doesn't change. The body continuously covers a distance of 6 meters along x-axis, 6 meters along axis, 6 meters along axis per second. In every second, it covers a distance of 6 meters per second. But during the vertical course of motion, its velocity or speed changes and moves in the projectile path. So, velocity along x-axis remains constant, and the body of the projectile moves with a constant or uniform speed along x-axis. And with changing velocity, and what is the change? What is the amount of change? You can see that Vi sine of theta was initially given, and it doesn't change. Vi sine of theta is a constant term at certain angle. When we throw the ball at some angle theta initially, then theta is fixed now, and Vi sine of theta is a constant term. The only term which changes is gt, which is dependent upon the time. G is a constant value 9.81. As the time changes, this term changes. So the overall velocity along y-axis will change because of this term. What is the displacement? The displacement along the x-axis will be equal to velocity into time. The velocity along the x-axis is Vi cos of theta, which is once given, then it remains constant throughout the time. And as time increases, distance along x-axis of the projectile ball will increase. Similarly, from the second equation of motion, we can calculate the distance along y-axis. As we know that second equation of motion is equal to Vit plus half gt square. By putting the value of parameters along y-axis, the distance is denoted in the y-axis by y, capital Y, and initial velocity along y-axis is Vi sine of theta, time is t, and the acceleration in the upward direction, as we are discussing the upward motion, the acceleration is negative. So we put the negative sign over here. So if the velocity is Vi at the starting time with an angle of theta, then the body has two components, Vi cos of theta and Vi sine of theta at the starting time. But after some time t, if the ball reaches at this position, then the initial velocity which is shown by the yellow vector, is changed to a green vector, or the initial velocity changes to some other value represented by the green vector. How much change has occurred? You can see that a red vector represents the difference between the two vectors. This amount of change is actually minus gt. As the time increases, the value of red vector increases, and the change becomes more and more. The direction of green vector becomes down and down. As ball moves forward, the velocity of the ball or the green vector, the direction of green vector becomes down and down because of the increase of red vector. As this is the term amount of value which is changed in the final velocity. Initial velocity was vi sine of theta, shown by this vector. This is a component initially given along y-axis, and this has decreased by the amount of red vector. So the difference will be this brown vector along y-axis, and along the x-axis, that is vi cos of theta. The resultant velocity along at the point t will be a green vector with two components. Along x component will be the same as initially it was given, but the y component of velocity will be changed, and it will be equal to vi sine of theta minus gt. So from the above discussion, we can infer, or we can deduce the result that throughout the motion of the projectile, the velocity of the body, the direction of velocity of the body, and the magnitude of the velocity of the body or the projectile will change, and its direction continuously changes, and the body follows a trajectory which is similar to the parabola shape. This shape is known as parabola. And ultimately, ball falls down. But in the downward motion, you see that acceleration along x-axis will remain as usual, will remain the same, that is 0, because there is no change in velocity along x-axis during the movement of the projectile. And this is because of the reason that no force is acting along x-axis. But there is an acceleration or velocity change during the y-axis, during the vertical movement, or we can say that, we can say that, and there is a acceleration along y-axis. It means that there is a change in the vertical component of velocity, and that is equal to minus 9.81. During the downward motion, this acceleration is positive. Acceleration is increasing. Along x-axis, there is no change in the velocity. So x component of the velocity, the downward motion, remains constant, and acceleration is 0. But the vertical component of velocity changes continuously, and velocity along y-axis in the downward motion continuously increases, and the speed increases at the rate of 9.8 meter per second square. So initial velocity during the downward motion, it becomes 0. We know that when the body starts falling down, then initially it was stopped at the highest point, and then it starts moving down. So over here, the initial velocity will be equal to 0. And the vertical component only will be equal to gt. And the displacement, which was covered by putting the value of vi sine of theta is equal to 0, as the initial velocity during the downward motion is 0, the displacement covered by the projectile during the downward motion from the highest point will be equal to half gt square. So the trajectory, to get the trajectory of the projectile, we have the following equation, and this equation represents that the trajectory is a parabola. This shape is known as parabola. You can see that the distance along x-axis is given by this equation and the distance along y-axis is given by this equation. If we put the value of t from first equation into the second equation, it means that we eliminate the value of t. By using these two equations, we get the result. And this final equation is known as equation of parabola, or this is the trajectory of projectile, and where tan of theta is a constant value named as b, and this whole term is also a constant value as theta is initially given and that is constant, first given then fixed, and vi also is a constant value, so this whole term is a constant represented by a. And this is the equation of parabola, or when someone draw a graph by using this equation with some fixed values of a and b and changing the points or the values along x-axis, we get the value of y along y-axis, and the graph will be a parabola. And this shape is known as parabola. If someone want to calculate the total time of the trip of the projectile, how much time it takes in the upward and then downward motion, what is the value of the complete time of the trip of the projectile, we can calculate it by using this equation. As we know that the vertical component of distance covered by the projectile can be given by this equation. Initially, we can say that initial velocity was vi and the angle was theta. But when it reaches to the ground again, its height will be 0 again, and the vertical distance along y-axis will be 0 again. So putting the value of y is equal to 0, we will get the value of time as shown below. And over here, we can get delta t, which is the time for complete round trip. So this equation is very helpful for getting the time. Another way of calculating the total time is very easy. And that is, first of all, you calculate the time for reaching the maximum height, and then that time will be equal to the time for reaching the downward or towards the ground, and the sum of both will be equal to total time. Or first of all, you calculate the time to reach the maximum height and then double it. It will be equal to the total time delta t. It is important to mention here that if you see by moving this term to the left hand side, it will be equal to negative sign, and by putting it over here, negative sign can be placed over here, and when we put the value of g, it will be equal to minus 9.8, and negative sign will balance the negative sign, it will become positive. Now we want to find the horizontal range. To calculate the horizontal range or the horizontal distance, it's very easy. As we know that total distance can be calculated by speed into time. The along x-axis speed is vi cos of theta, and time, complete time of the trip is delta t. So vi cos of theta into delta t gives a complete distance. And we know that delta t for the complete round trip, or the time for the complete round trip, is equal to this value. So put this value in the above equation and we get the horizontal range, or the distance covered by the projectile along the x-axis, and that is equal to 2vi square sine of theta cos of theta. And we know that sine of 2 theta is equal to 2 sine theta cos of theta. It's very simple. By using this trigonometric function or formula sine of alpha plus beta, where alpha is equal to theta and beta is equal to theta. And we can say that sine of alpha plus beta is equal to sine of alpha cos of beta plus cos of alpha sine of beta. So final result is vi square sine of 2 theta over g. For calculating the horizontal range, we use the formula vi square sine of 2 theta over g. For different values of theta and initial velocity, we can get different ranges. But if velocity is fixed and we only change the angle, we can observe that the maximum range can only be achieved if the sine of theta has a maximum value, and this term sine can have only maximum value of 1. We know that sine of theta has a maximum value of, sine of theta varies from -1 to +1. It means maximum value of 1, and maximum value can be achieved at 90 degrees. Sine of 90 is equal to 1. If 2 theta is equal to 90, then theta is equal to 45. So if theta is varied from 0 to 90, then it means that if by putting the value of theta equal to 45, we can get the maximum range, or graphically we can show that by increasing angle, the horizontal range increases. Green line shows that at 15 degrees, range is less, almost 30 meters. By increasing angle to the 30 degrees, range is further increased to 60 meters. By increasing angle to 45 degrees, range is further increased almost 62, 63 meters. And similarly, by increasing angle further, if we increase angle 60 degrees, the ball comes back, other horizontal range decreases, and at 75 degrees, the horizontal range further decreases. It means that the maximum horizontal range can only be achieved at an angle of 45 degrees. What is the maximum height? Maximum height can be found out by using the simple mathematical formulas, as we have already proved those formulas, that Vy is equal to Vi sine of theta plus Gt, and Y is equal to Vit sine of theta plus half G. At maximum height, final velocity along y-axis, we know that the body will stop at the maximum height, and the final velocity along y-axis, the vertical component of velocity, at that maximum height point will be equal to 0. As we know that when the body moves upward, its velocity decreases, and when it reaches a maximum height, its velocity, vertical component of velocity, will be equal to 0. So putting the value of Vy is equal to 0 in the first equation, we get the uptime, and we know that this uptime is half of the total time. So if you multiply it with the 2, it will be equal to the total time of flight, as in the previous slide I have already mentioned. The total time can be calculated by calculating the uptime and multiplying it by 2. Now, for maximum height, I put the value of max uptime in second equation, and we will find the height or the vertical distance at the maximum height. Just put the value of t up and simplify, we get vi square sine of 2 theta over 2g. And you see that 2 is in the denominator. By taking the LCM, least common multiple, 2g will become the LCM, and this term 2 will become with the first term, 2 vi square sine of 2 theta, sine square theta over g. So, and over here it is vi square sine square theta over g. So the final result will be equal to vi square sine square theta over 2g. You can solve it by yourself, simplify it by yourself on the paper. So, and at last, we summarize the whole discussion that projectile motion is motion with a constant horizontal velocity combined with a constant vertical acceleration. Number 2, the projectile moves along a parabola. Number 3, a ballistic flight is that in which a projectile is given an initial push and is then allowed to move freely due to inertia and under the action of gravity. An unpowered and unguided missile is called the ballistic, and the path followed by it is called the ballistic trajectory. Thank you, students, for watching the video, and please carry on watching the videos on YouTube channel, and please subscribe this channel for getting more information and more informative lectures on the physics, chemistry, math and other subjects. Also visit the website www.cancollege.com for more information. Thank you.